Hello, afternoon, evening, good morning, wherever you are, whatever you're doing. I hope you're all having a wonderful day. Today is going to be just a little short, well, I don't know how short it'll be, but I'm going to make a quick video talking about planar. I'm going to talk about the history of planar, well, not the history, but the lineage, I guess, of microplanar for use in IEMs. Kind of where they started, where they went, and where they're going. Now, I don't know the complete history. This is just little bits and pieces of it. Obviously, if you want to know the complete history, you'll have to look online, look on forums and whatnot. I'm sure, what is it? The Hi-Fi forums. I can't remember the name off the top of my head. But, so basically, back in the day, oh, and we're also going to be tearing apart this little guy right here, this KZ PR1. I'll take it apart and I'll show off the driver for you guys. So, to get started, the first planar that I ever owned was the Tin Hi-Fi P1. I bought it used off of Discord. Somebody on Discord sold it to me for $75. This is around the time that it ran for 150 bucks. That IEM had a 10mm planar driver, and for anybody that's familiar with the P1, sounds good, has good tuning. I don't remember too much about it, but except it has really high power requirements, so it takes a lot of juice. And to really get the most out of the driver, you had to seriously give it a lot of power for it to really sound good. But they were good IEMs. They're not bad by any means. They're well tuned. They have good bass, pretty good treble, pretty decent timbre for the for having a planar. All around, you know, like small size for all metal builder, pretty lightweight. Decent accessories. I think they were like $150 new. But all around a good IEM. And so that was the first one that I owned. And then I tried the i3, which is a hybrid planar, DD, and BA. And that one uses same kind of 10mm planar driver. I think it was a revision, so it had a more sensitive planar driver, especially considering they combined it with BA and DD. And I actually got those for free because Amazon did not ship them to me on time, so they offered them to me for free. I listened to them. I didn't really like them. They were just really flat and boring sounding. I just didn't like them. So I ended up taking them apart. And I also took the P1 apart, but I didn't actually take it all the way apart. I just took the backs off. The i3 I took apart all the way. And I'm pretty sure the planar was a different driver. Now the shape, the appearance was the same, but I'm almost positive it was a revised driver because the sensitivity was a lot greater. And I'll go over that in a second. Kind of show you guys what I'm talking about. Then I had a friend of mine that lent me a bunch of planar drivers. He lent me the Tin P2, the Tone King P10, the gosh, what else was there? I'm trying to think of what else there was. P2, P10. I want to say the P1 Plus, maybe? I don't know, there was a bunch. But anyway, he lent me a bunch of IEMs in like 3 of them were planar. So I got to try those out, listen to them. They were alright. Nothing really stood out. Tone King was meh. And we'll actually talk about the Tone King in a little bit. So yeah, so planar IEMs have been around for a little while, probably about 2 or 3 years, at least the microplanar. When I say planar IEM, I'm talking about microplanar. There is a company that manufactures a larger planar for use in IEMs. I do not remember who it is off the top of my head. At least I can't think of the company. Like, I know what the IEM looks like, and I know their symbol. It's like a triangle, but I don't know off the top of my head what the name of the company is. So anyway, so long story short, I'll get into this little history, this little overview. So here we have the Tin Hi-Fi P1 sort of model of driver. Now this is a 10 millimeter, and this is pretty much identical to what you would have seen in the P1. Let me take this off. I was actually messing around with the tuning because I was trying to tune a hybrid with them. So, come on. So this is the back of it. Okay, so you got your 2 terminals. You got these little gold rings right there. So there's these little pegs that come from the right and left, and the pegs go down either side, make contact with the diaphragm. So there are like 3 revisions of this driver, and each one, I believe, has increased sensitivity. I don't believe the tuning is very much different. The tuning may vary a little bit from driver to driver, but for the most part, what I understand is the sensitivity has changed. And there's various things that go into having, there are various things that go into having, increased sensitivity. And that is the type of material used, whether or not the diaphragm has traces on one side or both sides. For anyone that's not familiar with how a planar driver is made, there are a series of magnets that run parallel to the driver. The driver is completely flat, therefore occupies one plane of physical space. And basically there are, at least the way that these are manufactured, the membrane or the diaphragm is made out of like a PET or like a Mylar type coating. It's like a plastic bag almost, like a low density polyethylene kind of thing. Anyway, so it has a little bit of give to it, and basically there are traces that are deposited onto its surface. Or they're etched. So basically they'll take like a sheet of copper and they'll etch like a zigzag. So it'll do something like this. So you'll have like a wave pattern. Okay. And that'll be physically either deposited or etched. I presume etched onto the material itself. So say this blue tape is the diaphragm, this will be the traces, and they'll try to maximize the volume. So say your driver is round, okay, so they'll try to maximize the surface area, and what they'll do is they'll go around, they'll take the traces and they'll start zigzagging around the circumference. They'll go up through the middle, and they'll enter like a side of the driver, and then on the side will be another deposition or another piece of copper or whatever the material is. Sometimes it's copper, sometimes it's aluminum, sometimes it's a mixture, but there'll be like a pad, and that's basically where the contact where it makes contact. So right here, so these two. So right there and right there. So there'll be like little pogo pins or little springs that'll go all the way through down to the front of the driver, and they'll go boop, boop, and they'll make contact with either side of the driver. So, but either way, it's one continuous wire almost. So the other side, you know, it'll make a few more loops, go around, kind of sneak in between itself, and that'll go around basically until it hits the other side, and there'll be the same thing. There'll be a like a deposition or a what do you call it, area where the copper's not etched, and you'll have your two terminals, so positive and negative. Okay, so that's basically your diaphragm, and then on top of that you have a series of vertical magnets that run along parallel to the driver itself. It can be one set of magnet, aka single-sided planar, or it can be on both sides, which is double-sided planar. Now the strength of the magnets, the number of magnets used, the proximity of the magnets to the driver itself all factor in the sensitivity of the driver. Same thing with the amount of space. So there's only, so with a, let me see if I can show you guys real quick. Give me 1 second, I'm just going to pause for a moment. Alright, so I'll find a good way to explain this. Oh, I need another pair of tweezers. There we go. So, let me try to zoom in on this. Alright, so with a dynamic driver, the coil stands off at like 90 degrees, so it doesn't run parallel with the diaphragm. So basically, the only thing that limits you from adjusting the sensitivity is the height or the depth of the coil. So I can always add more turns, or even the diameter. So usually a coil is made out of, so there's turns, but there's, when you refer to it as turns, it's how many times it kind of folds back in on itself. So you can have 2 turns. It's still one set of windings, but it can be 2 turns. So basically you'll have like a thickness of 2. So you'll wrap it all the way until it gets to the end, and then you'll come back around and you'll go back down again and wrap it back over itself, and that'll be 2 turns on the diaphragm. So anyway, that is the only thing that limits it. But when it comes to a planar driver, the thing that limits the sensitivity is how much space you have. So the size matters, and those have been some of the hurdles with engineering a planar driver, is you only have a limited amount of space because it only occupies one plane. You can't actually bring the traces out. If you do, you'll affect the sound of the diaphragm because the amount of copper adds weight, which can slow down the driver. And there are other things with planar. There are like various resonances and stuff. Planar has a tendency to resonate because it's like it's more like a spring. It doesn't have I don't know how to explain it. Every driver has like its resting point, or it's like zero position. So like a DD, moves in and out and kind of rests at zero. Well, the DD or the dynamic driver, the diaphragm, is free to move. The only thing that restricts the movement of the diaphragm, here, this is a good one to use. So the only thing that restricts the movement of the diaphragm is the surround ring. So there is a little bit of elasticity in it, which it'll want to return to its resting position, but you can make it thinner or thicker out of whatever material you want, or you can make it bigger so you can have more movement. Now with the diaphragm, there's tension. It's constantly in tension. So it deforms itself. Basically, so the traces act like an electromagnet, and they pull or repulse to and from the magnets. And basically, the thing that controls the speed or the sound of the driver or its capabilities are how quick it can move and how much it can move. So it can only move a certain amount because it's deforming on itself. I don't know. I'll kind of show you guys. I'm not really good at explaining this stuff, but you'll see when I go to show you. So anyway, dynamic driver has a little bit more give, or a little bit more leniency in the way that you can tune it, the way that you can design it. It's more forgiving because it doesn't have to occupy just one plane of space. So there are these challenges that we've had with planar drivers, and that's why planar drivers have not been very sensitive, at least the micro planars, because there's not, come on, oh my goodness, you're killing me, because there's not a lot of physical space, there we go, because there's not a lot of physical space for the voice coil to rest on. And then on top of that, the coil itself is fighting against the tension of the driver. So, like for instance, these two pegs here, they're to keep everything aligned, but the diaphragm itself, it's hard to show you guys. I'll show you with the driver, but basically the diaphragm is constantly being held in tension. The way they do that is they use a piece of PCB. What do you call it? It's like circuit board material. I can't think of the name off the top of my head, but that's basically what they do, is they sandwich it together in between two layers of PCB, and that kind of acts as a like a tensioning ring that holds them in tension. Now, for like larger drivers, like earphones and headphones, they use screws, and the driver gets stretched over the screws, and then they pinch it together in like a plastic ring. So, all right, enough rambling about that. So basically, this was like the first generation of driver. There's another generation that came out kind of recently. It's a 12 millimeter. This is the 10 millimeter. The 12 millimeter looks almost identical to this, but again has more surface area. So when they etch away the copper, or they deposit the copper on the diaphragm, there's more physical space, so they can add more copper. And like I said, there are other tricks too to add more copper. So you can do single-sided, or you can do it on both sides, which is not really something I've come across. Normally every planar that I've come across has been single-sided, at least microplanar, but I'm sure there are some out there, especially the most recent ones, that are probably dual-sided, especially when the manufacturing techniques become more advanced. So there's that. So that is the 10 millimeter. Then came in this bad boy here. Now, this is a descendant of the 14.5 millimeter driver that was in the Tone King P10. So there is a metal planar driver, and it has literal screws holding it together. So there's a screw here and a screw there, and then when you look at the back of it, there's a nut here and a nut there, and that is literally how the driver is held together, kind of like the alignment pins in this driver, so like those right there. Okay, but anyway, so that was the first generation, and then this, from what I know, is the second generation. And this one, I'm not sure about that other one, but this one is actually, I believe, dual-sided. So there are magnets on this side here, and I believe there are magnets on the other side. Actually, let me see. I'm going to do something naughty. Yep, there we go. Well, I guess that's good enough. But anyway, you guys see? Here, let me get my camera sorted out. As well as get this crap off, whatever this crap is. Alright, there we go. Alright, so you can see with this diaphragm that there are magnets along the front. So yeah, I'm pretty sure this is double-sided. But inside, on either side of the magnets, see these lines right here? See there's another one there. See there's two there, there's one there. And there's another one right next to it. There's two there. Those are the traces. That is the actual diaphragm itself, and the metal that is either deposited onto it or what has not been etched away. And let's see, so we got 1, 2, 3, 4, 5, 6, 7. So 7. So this is 14 magnets. So basically, this was one of the first designs of planar. And as far as the IEMs that these were featured in, this came out of the P1 Max, but this is actually an older version of the 14.5 millimeter because of this square or rectangle entryway. But yeah, so this is a 14.5, and then you can see the construction has been cost down, so it's more affordable to produce. So everything is made out of plastic. The magnets are retained by the plastic now. The diaphragm that's being held within this PCB material is just exposed. It's not in a metal shell. And then we'll get to talking about this. This is actually a tuning cavity. So this is a volume of air that rests behind the driver that acts as like a cushion that dampens the driver and adds to the tuning of the driver. and I'll actually show you. Let's see. So this is what it looks like by itself. Okay, so that's literally all it is. It's just like a 3D printed plastic piece that acts as a cavity, a tuning cavity or a tuning chamber that rests on the back of the driver, and then it has a dampener which allows the pressure to vent. But yeah, basically it just acts as a cushion of air, and it kind of slows or adjusts the rebound of the driver. Excuse me, for tuning purposes. So this whole back area, come on. So this whole back area is not attached to the driver. This whole like crescent moon kind of shape. This whole like crescent moon kind of shape. This is all the tuning cavities. So the actual driver itself is from here to here. So from there to there is the actual driver. Everything else, so from here up, is the tuning cavity. And then you can see with this driver, they're using like a flex PCB. So it's basically it's like a foil, and the leads are actually attached onto this foil, and then you see there's like a little alignment peg to kind of hold them in place. So this is also indicative of the older construction method. This flex ribbon PCB kind of material that they're using here. Because if I were to actually pry on it, you can see it flexes. It's just a ribbon, that's all it is. But it makes contact with the pins or the contacts inside here. So then you start getting into IEMs like the and I'm not sure because I've never taken one apart for myself, but the timeless and the S12 and I believe the S12 uses the same driver, but there is another revision of the 14XX millimeter driver, planar driver, which is this. And this is actually a higher quality but more expensive planar driver. Come on. There we go. So this is kind of the same thing. You can almost make out the rectangle. So you can almost make out it starts here and goes across. And then same thing with the bottom. Kind of goes across. Yeah, you can see it a little better there. But anyway, this is kind of similar, but instead of using a plastic chassis, now it's the plastic sandwich, but it is encased in metal, and then it has this mesh or this dust covering that allows it to breathe, but also gives it a little bit more space for the sound to emit from it. And I'm sure there are also other tuning properties to it, like reflectivity and whatnot for the treble. But anyway, if you look at the construction of this unit, instead of that flex PCB that we saw, now there is an actual second layer of PCB, and this is much sturdier for the solder connections. So you notice with this one, see that there is, I'm sorry for my gross fingers, but I do a lot of work, so they're dirty. So you see this lead is missing here, but there's a solder lead there. So this is something that happens quite often, is if there's any kind of resin or glue or whatever that's kind of adhered to the terminals and you go to take the IM apart, well, this will rip and it can rip right down in the middle because this stupid little peg here. So this is not very good. If this rips, and say it rips up inside this tuning cavity here, that means you have to take off the tuning cavity, wire the lead inside it, and then like create a little cutout for your wire to protrude, and then you'll have to seal it back up again. So it's just a pain in the butt, and it's not a very solid method of construction. Whereas with this diaphragm, it's an actual PCB, so it's a solid surface. Plus you can see it's crimped. So you see this crimp that goes all the way around it. So they physically crimped it in, so there's no getting it out. So you can tug on it, you can yank on it, and I mean, if you guys know anything about flex PCBs versus actual like PCB boards, these are much more durable. But anyway, so this is the diaphragm, and then this little sponge material here, this is the tuning paper. So this couples it to the housing. It helps eliminate vibrations from the driver to the housing, but it also adjusts the spacing of the driver inside the housing, so it helps with tuning. So anyway, so that is how it is. And then here is one that I have where I have already removed that. Let me actually try to get it off a little cleaner. So this is what it looks like without it. Alright. So same thing. Here you have the driver. You can kind of see inside it. And then forgive the ugly solder terminals. I was just playing with it. But so this is basically what it looks like without that tuning cavity on the back of it. And these were actually a prototype IEM, so I'm not allowed to talk about them. But so basically this is, I guess, a tuning paper, but it's also like a mesh to keep any debris out. You can see it's much larger than the 10 millimeter. Which kind of has the same thing. But this is what it looks like without that tuning cavity on the back of it. So, same exact driver. Alright. And now you can see the whole exposed PCB. And also, because the PCB is exposed, you can now see the contacts that go through. They touch those little pogo pins I was talking about. There's little gold pins that go down either side for the plus and minus of the diaphragm. And then you have these alignment pins, which allow them to, during assembly, it allows them to just add the layers on and just sandwich them together. So that's that. And then the tuning cavity itself, where did I have it? What did I do with it? I just had it. Oh, there it is. So basically, this, come on. So this just kind of rests on the diaphragm, or on the planar, like that, and then is glued in place, and that completes the diaphragm. Now, in the Tin Hi-Fi P1 Max, there is even another step to it, and I will show you guys. Where is it at? There it is. So again, back to this driver. Come on. Oh, you fucker. Seeing the marker, so it doesn't want to focus in on the driver. So anyway, so this is the P1 Max driver, and you'll notice again, same thing with the tuning cavity, but for whatever reason, and I don't know why, I don't know what the what the reasoning for it is, but they added on yet another tuning cavity on the back of this one. Okay, so inside the P1 Max is actually this right here. So it goes front of driver, or the magnet structure, diaphragm, magnet structure, the terminals and whatnot, the tuning cavity, and then another tuning cavity on top of that. And this second tuning cavity, because if you know anything about tuning dynamic drivers, everything is controlled by the dampener here. So once you're past the dampener, there really is no difference. And this is why I always say that there's no such thing as a open back IEM. Or if there is, I haven't personally come across it, because in order for there to be a truly open back IEM, they wouldn't be able to use the tuning dampener on the back, because the dampener is what restricts the airflow. It's a mesh. It's a very fine mesh, and only so much air can flow through there. There's only so much sound pressure that can come across. So anyway, I just thought that was interesting. But yeah, this is for the P1 Max. So those are kind of your lineage of in-air monitor planar drivers. So you have your 10 millimeter, like in the P1, the Tin Hi-Fi P1, the OG, and it had really bad sensitivity, required a lot of power. And then you have your Tri-i3 and your i3 Pro, which became a revision of this. This driver itself is actually from the Audiodyne, something Dyne, the PP1. It's the planar, or PD1, I'm sorry. Yeah, it's the audio, I think it's Audiodyne PD1. Harmonidyne, that's what it is. It's Harmonic Dyne PD1. That's what this is out of. So anyway, so a lot of IEMs use this kind of driver here, and I believe this is actually a newer revision of it, a higher sensitivity. And then, like I said, the same company released their 12 millimeter version, and then it went from that to these 14 millimeter, more larger, more surface area drivers, and the like your MX500 form factor, the 14.5 millimeter, like your earbud form factor driver. Those are all 14.5 and 15.5 and whatnot. But anyway, so then there was this driver, and the one before it was the OG, and had, like I said, had screws in it, metal construction, and then this came after that, and then you have one of your more recent 14.5 millimeter planar drivers. Oh, you could actually see the magnets there for a second. Yeah, you kind of see that? See the lines? But anyway, so yeah, so this is your more modern. And then you have stuff like this. This is the Kinera SPD, and this is a square planar driver. And a lot of people like to say that this is actually a dynamic driver. No, it's not. Is it a conventional planar like any of these? No, it's not. It's something completely different. It's something new. Here we go. I'm not going to take it apart because I've already taken one apart, and I only have so many to use. but I will show you what it has in common with a dynamic driver and what it shares in common with a planar driver. Because I've wanted to explain this for a while now. People are like, oh, it's a dynamic driver. Oh, it's a planar driver. No, it's its own thing. So, here's a dynamic driver. Here is the SPD. Let's see if I can zoom in a little bit more. Let me try to get some of the light away from it so you can see it a little better. There we go. So here's the SPD driver, and here's a like a milky white liquid crystal polymer kind of like LCP type driver. This is just a cheap driver. But anyway, you can see that instead of, and I'll actually show you a little bit more of this later, but instead of having the wires etched inside the diaphragm is its own thing, and it has a coil attached to the back of it. So just like in a dynamic driver where you have a coil of wire, on the SPD you have a coil of wire, but instead of being perpendicular or at an angle like a dynamic driver, it is completely flat. Okay? See? It's totally flat. Alright? And then this is the face of the driver. It's like a metallized film layer. And if anybody's familiar with the solo Barrick woofers, like the L7 whatnot, it's similar to that. So another reason why this is not like a dynamic driver is because in a dynamic driver you have a magnet structure. Let's see, I'm trying to find it. Here's one. Alright. So in the dynamic driver, you have a magnet. They call it a motor structure. So basically, this is the motor, aka the magnet of the driver. And your voice coil interlocks inside this magnetic gap here. Okay. So it actually fits in between the magnetic gap. And the magnetic flux is what they call it. That's the field. So the magnetic flux travels across this gap here, okay? And the coil, which is the electromagnet, repels from this field, okay? So it's critical to a dynamic driver that the voice coil rests inside this gap. This gap is very intentional, okay? But with a flat driver, with the SPD, you don't have a gap. So how do you achieve the magnetic flux, or how do you construct the flux for it to operate within? Well, just like a planar, where you would have a magnet on either side, same thing with the SPD. Let's see if I can focus in on it. So the front of it, behind this metal plate, and you can just barely make it out in the corner, there is a magnet. So there's a large magnet on the back of this plate, and that's the whole reason for this plate right here, is there's a large magnet. And then on the opposite end, in the back here, you have a series of 3 magnets. Okay, one is aligned like north to south, and then the other 2 are aligned south to north. So they're reversed. And what that does is that creates a magnetic flux that does something like this. Okay, so it moves like that. So it starts from the back and kind of moves its way across. And so essentially that is your gap, just like a dynamic driver, but not. It's more like a planar, basically. So it's a coil that still operates in that within that gap, but the gap is in free space. Sorry, I'm not really good at explaining things, but instead of an actual gap, the diaphragm moves in free space, but its area of flux is similar to that of any driver. So, but it more, in that sense, meets more the criteria of planar than it does dynamic, because it does not, the coil of wire is not perpendicular to the driver, and does not, it's not necessary that it fits within a gap. There is no gap. It floats in free space just like a planar. And instead of having the front of the driver completely open like you would a dynamic driver for all the sound to leak out, you have this metal plate in front of the majority of it, because the plate is structural to hold part of the magnetic structure. So, very interesting driver, and I will actually talk about these a little bit more. But as far as the sound goes, yes, it sounds more like a dynamic driver. As far as the principles of operation, it's more like a planar. Now, the other thing that's different, like I was talking about, one of the negatives of planar is that the diaphragm itself is constantly under tension. This is not. There's a built-in surround ring, and you can actually see the ribs. The ribs are to keep the driver from kind of shifting from side to side. It's to keep it straight. Okay? And basically, if I were to take this, kind of rest it up on its side, well, you can't really see it, but it's just a little ever so domed. Okay? So this driver moves a lot more effortlessly than a planar driver, but at the same time, I'm not sold that it's as fast, because it has more weight to it. So just like I said with a planar, them having to etch the copper or deposit the copper onto the diaphragm, this is like an actual plate, and then you have the actually, from what it looks like the plate is adhered to this this like mylar, or this LD. It's like a rubber compound. So this attaches to the whole of the driver. Yeah, you can see it peeling back there. So basically, this material, or the driver material, is actually bonded onto the diaphragm, this little metal sheet here. And then you have the coil that's bonded onto that. So there's a lot of weight. So basically, what I'm trying to say is that there's a lot of weight for those magnets to move, and there's also less of them just because of its design. So I'm not sold on it being faster than a planar driver, but it definitely doesn't have the timbre of a planar driver, because it's not constantly under tension. It doesn't have the same resonances, and it's also a lot weightier. So it sounds more similar to a dynamic driver, but it's a good driver. It's not bad. There's nothing wrong with it. All right. So let me zoom back out. Let me reset my light. And I'm starting to lose my voice. I apologize. I've been working all day and been talking all day. So that gets us to KZ's latest offering, the was it the PR1? And it's a good IEM. Sounds pretty good. Tuning's decent. Sensitivity's alright. For a planar, $60 some odd, it's not bad at all. There we go. It's not bad at all. The construction's good. KZ always has good quality as far as construction's concerned. The quality of components. The only thing that I ever have any issues with are the designs, and then the QC with the designs. Sometimes the designs are a little too complicated for the people that assemble them, and there's some minor oversights. It's just an overcomplicated design. So, but it's necessary for ease of manufacture, because these are super easy to pump out. Because of the three-piece nature of the shell, so I could attach any back to it, I could attach any front to it, different nozzle. It would only require one piece, and everything fits together like Legos. All their connectors are the same, so it's really clever construction. Honestly, the engineers at KZ are pretty good. They definitely. The engineers that design the IEMs, like the physical aspects of the IEMs, definitely do a good job. Tuning, they do all right. Not quite my preference, or at least I think they could do a little bit better in some circumstances, but not bad at all. Not a bad company whatsoever. Now this IEM I'm not going to keep, so I'm just going to destroy. I will show you guys the destruction. If I can get it open, goddamn. Sorry, 1 second. I need to find my snips. Here they are. These are my go-to. I love these guys. This is how I get a lot of shit open. Alright. So, a little bit about the PR1. It is a 13.5 millimeter driver, so it's a little bit smaller than the other ones that I just showed you. The construction is a little bit different, and we will go over all of that. Do I believe it's manufactured by the same company as those others? No. I think this is a different driver entirely. Created in-house for KZ, or they could have bought it from an OEM, but they have some sort of exclusivity rights to it. I'm not sure. Things work a lot different in China, so any company could use this technically. But KZ is one of those brands that has a lot of horsepower behind them, so they can have drivers made specifically for them. And in fact, Kinera, they kind of do similar to that. They have drivers that are made for them. All right. So there is the front of the shell, and you can see right in the middle we have our dampener for the front chamber. Let me bring this in close. Okay, so there's the hole. You'll notice the hole's square, and that is to meet up with the rectangular nature of the driver. So basically the sound kind of funnels into the driver in a kind of a square. So it tapers down from a rectangle to a square. It's kind of cool. It's an interesting thought. I'm not sure if it's necessary for tuning, but it's cool. And as you'll notice, this is not, so these IEMs are not made out of metal. This is a electroplated plastic. So it is a layer of metal on the very top, but it is plastic that is covered in metal. Okay. So there you go. It's the same construction as the ZAS. So it is metallized plastic. So still really durable, still good quality. I believe it is the back plate is the only piece that is actual metal, and oh, there it is. Yeah, here it is. So I believe this is the only piece that is actual 100% metal. I could be wrong, but no, that definitely sounds like metal. Yeah, that's 100% metal. So yeah, the faceplate is made out of metal, completely metal. Oh, the vents on the back are just for decoration. Like I said, in my opinion, there is no true open back IEM. They look good, and they're not lying to anybody. They said in their marketing that there's plastic behind there. So they said it from day one. So don't anybody think that, oh my God, they're fooling us. No, they already said it. So but the ones on top, oh no, those aren't real either. So, but yeah, so basically, yeah, there's no vent. All right, and then on to the good stuff. So this is the intermediate shell. Okay, so like I said, this is like a little Lego piece. You could swap it out with other IEMs from KZ, and it would fit. And you notice, I'll just show you guys real quick. There is hardly any room in there for anything else. Like, they fit that driver in there, and that is it. See, there's very, very little room around it. So around there, there's cutting it close. They could have moved the driver up a little bit, but then it would be further from the nozzle, so that wouldn't be a good idea. Alright, let's take a look at this bad boy. So this is a really cool driver. Let's see, let me zoom into 2.0. Yeah, there we go. Alright, so this driver is really cool. First off, let me grab my tweezers again. So first off, you can see the pads. So there's one there and one there, and those are what make contact with the terminals on the back here. So you can see right there and right there. They're little pogo pins. You can actually kind of see the deformation right there, but there's one right there. There's another one right there. And yeah, you can actually see where the diaphragm kind of deforms a little bit. See right there and right there. And then you have traces that go along the edge, and they wrap around, and they go back and forth and back and forth and back and forth. And this is the same layout of the other drivers that you saw. So 7 magnets. They claim N55, but I'm not sold on that. These don't look like any N55 magnets I've ever seen, but I could be wrong. It wouldn't be the first time. Definitely been wrong in the past. Let's see. Come on, baby. Want to get nice and close in on there. And so you can see the back construction of the driver is very similar to the other ones that I showed you earlier, the ones with the rectangle entryway. You can see that it is a flex PCB, and then there's that little peg. But this time it is covered in glue. You can see there's glue right there. And And then you have the same thing, the tuning chamber. So this metal piece right here is the tuning chamber. This is the first time I've ever seen it made out of metal, which is really cool to see. Also, notice the clear plastic. That's also really cool to see. It's always cool when you can see through the driver. If I wanted to, I could coat this with resin and make it really see-through. Oh, uh-oh. The diaphragm is single-sided, which I'll show you guys in a minute. Although there are magnets on both sides. This is a dual magnet IEM, so 14 magnet planar. And let's get this tuning back off real quick. See if I can do it without stabbing my hand. There we go. All right. All right, boys. Let me get some of this glue off. So yeah, basically, that is the back of the PR1 Hi-Fi driver, and all the don't get me wrong, I believe all the KZ IEMs all share the same driver, at least up until right now. They may have a different driver for later, but they're just, the IEMs themselves are tuned different. So the drivers are all the same, but the IEMs are tuned differently. And yeah, that's it. It's a really novel design. It's really cool. You can see actually the plastic pegs that go straight through. So they're the alignment pegs, and they just kind of sandwich it together. You can see the same construction as the PCB. So you can see the PCB there. Alright. The gold pins, the little pogo pins I was telling you about, that make contact with the PCB. So you see there's one on that side, and there's another one on that side. You can see that one really good. Okay. And then again with the diaphragm. So, and then I'll show you guys the inside of the tuning chamber. So there's nothing fancy with it. It's made out of all metal, but it's just a little tuning chamber with a dampener on the back. Okay. And let's line it up with our 14mm driver here. Actually, let me do this again. Come on. There we go. All right. You can kind of see the difference in construction. And then you can see the side profile. So yeah, they're definitely a little bit different. And then let's take a second to compare the magnets too. I just want to take another look at this other one, and I want to compare and contrast it to the KZ. Oh, come on. There we go. Doesn't want to stay open. Sorry guys. This is all on the fly. Oh, you motherfucker. Come on, get off. Quit being a turd. Pull you off completely. Alright, there we go. Alright. So there you can see the two diaphragms. Actually, they might be made by the same company. I don't know, who knows? The construction is definitely a little different when you look at the two of them, but the material used in the diaphragm itself looks almost identical, and the magnets look almost identical as well. As far as the physical size goes, honestly, they're about the same. The KZ is just ever so smaller, but not by much. It's very interesting. And let me just do one last thing for you guys. Do I have... Let me just make sure I don't have one that's already got it removed. No, I don't. Alright, here we go. Alright. Just gonna remove the tuning filter. So yeah, definitely a small difference. There's definitely a difference in the plastic molding, that's for sure. That's very different. The construction is very similar. The dampener on the back is different. The magnet arrangement is the same. The flex PCB is a little bit wider on the KZ. You can actually see it's I'll explain what I'm saying. So it's thicker. See, it's physically thicker, and the one on this one is a little bit thinner. So the one on the KZ is like that compared to this one. So also a different method of solder used to attach it to the little pogo pins. With the KZ one, it looks like they just hand soldered it, but in this unit it looks almost like wave soldered or something, like some other method. So yeah, and then the PCB. All right. So one last thing before I go. We're already at an hour, so I didn't mean to make this last so long. I got food I've been waiting for forever, and I'm freaking starving. So this is where I'll leave it for you guys. So this is one that I've already taken apart. And I don't know, that might be the same type of thing that they used on the back. No, it's not, it's different. Okay. So anyway, so this is the magnet structure here. Alright. Just move some stuff out of the way. Sorry guys. Just give me 1 second to get situated. I know you've already given me a lot of your time, and I appreciate it. Alright, so here are the two magnet sections of the KZ IEM. Alright. Move that pin out of the way. That pin just sheared off. Alright, so there's your magnets on either side. And then here is the diaphragm. All right. Apparently, someone's saying it's like a silver coating. It's a silver diaphragm, which I guess it could be. It looks like it. Kind of makes sense because it's silver is actually more conductive than gold, from what I hear. So that would kind of make sense, especially if they're trying to lower the sensitivity. It looks like it is. So you remember earlier how I said there's two methods that they can use to make these diaphragms. They can either use deposition, like vapor deposition, which is basically where they take like a vacuum chamber and a like an arc lamp or whatever, and there is a piece of metal. It's like a cathode and anode. Basically, they run electricity through it, and all the ions go bloop, and they basically come off of whatever it is, the metal that you want to deposit, and it goes onto whatever material you're trying to deposit. But it's a very difficult process, and there has to be some sort of like mask for them to do this. So I'm not sure that it's probably just like routed, where they go through and they like laser etch it. It's like probably etched, laser etched or whatever, and then they just add on another sheet of material on top of it to finish it off. Come on. There we go. Alright, so this is the diaphragm. And yeah, I'm sorry, it's it's really busted up. Kind of broke when I was taking it apart. Could have been a little more careful, but I just wanted to see the leads. So you can see it's only single-sided. You can see how some of the wires wrap all the way around. So you see there's the terminal there. Or not, I'm sorry, the terminal's right here. And you see it wraps all the way around. Then it kind of zigzags and it goes around again. And it goes around down there. But yeah, so this is the actual diaphragm. And the material is very thin and actually very hard. Like this is like what do you call it? It's like the it's like the stuff they use for like a temporary tattoo. I don't know how to explain it, but it's like kind of stiff. And you can see too from the wrinkles in it. You can see that it's kind of like a stiffer material. So this is the back of the driver, and you can see that it doesn't reflect light the same way. So there's obviously something to it where it's like deposited on one side. It's like a sheet, and then they just add another one on to maybe the back of it. Sorry. I'm not sure. But yeah, it's very delicate. Very, very delicate. So, and the whole reason why I took this one apart is because I got like a speck of something inside it, and I was trying to clean it out, and I took a little needle, and I was just trying to dig out the piece, and I went boop, and just ever so gently went and poked right through one of the leads, and it stopped working. So after that, it was basically done. And like I said, with the whole suspension method, see, it's really loose now because it's obviously broken and cracked and all that. But if you look, you can see the PCB material. So that's how it's suspended. They like stamp it inside, and then they must like cut off the excess. But yeah, and they use all these like little dowels to align it, and then so same thing with like the magnets here. You see the little pogo pins, so those make contact with the driver, and then yeah, it kind of just goes something like this. And I wonder if the magnets are offset a little bit. No, it looks like they're not. Okay, so that'd be interesting if the magnets were offset. But yeah, so there are the 14 magnets. And yeah, that's everything in a planar driver. Along with the little tuning thing that goes on the back, little tuning cavity. So anyways, guys, I had a quick idea for this video, and I figured I would share it with you real quick, just to keep videos coming out. I promise I'll try to make my content a little better, a little more exciting. But I hope you guys enjoyed this planar presentation I had for you today. Anyway, again, I hope you're all doing well. Hope you're having a wonderful day, night, evening, afternoon. It was a pleasure talking to you, and I will see you again shortly. Have a good one.